Hey guys, this is Mr. Sal. We're just going to go over a quick lesson on reflections and some basic properties of reflection. So thanks for watching. Don't forget to like and subscribe and comment about the lesson below. I know that a reflection will not change the size of an image. I know that the line of reflection is halfway between the image and pre-image. I know that the line segment created by the image and pre-image is perpendicular with the line of reflection. So there are several words we need to look at on this one. Reflection. So far we've gone over one type of transformation. The first type, which is what we just barely completed, was translations. And now the second type of transformation is a reflection. Alright, a reflection, some of you guys use the wording mirroring or turning, I guess flipping really. Like we flipped the image on that last lesson from last time. So some of you guys have seen this before, right? Where like a mirror, and you take an image in the mirror, like, I don't know, a face like this.
Is that a face?
That's a face. It's a sideways.
I don't see a face there.
Alright, well, we would take this face,
It's just like a P.
and we see the eyeball right there is that far away from the mirror. Its reflected image is going to be the same distance, just on the other side of that thing. So we end up with something like this, I guess. Okay.
I can't do that better.
Now this
Can I do
one,
it?
this one shows that the line of reflection right here, which in this case would be the mirror, is halfway between, I guess, the eyeballs or the faces. And additionally, that last objective is saying that it's going to create a 90-degree angle, which is what perpendicular means. It's going to create a 90-degree angle there. Alright, in this one, we're going to reflect triangle ABC and figure D across the line L. So that line L is the line of reflection. Don't forget to label your reflected images though. Take 1 minute or a couple minutes to do that with your partner. Go. Which figure or figures were not moved to a new location on the plane under this transformation? Talk about that with your partner. Or in other words, were there any parts or figures that were not moved at all after the reflection? Notice point B was not moved at all because it is on the line of reflection here. Also, the line of reflection was not moved because it's the line of reflection. Okay. Keep that in mind because you'll have to know that once we start looking at more advanced stuff on this. Alright, now reflect the images across the line L. Label the reflecting images. Take a moment to do this with your partner. So this is what we should have gotten from that reflection. Once again, we can see that B is the same distance as from the line of reflection as B prime is, but in the other direction. Same with these other ones like J and J prime. This is the same distance from the line of reflection.
So much for nothing.
It's just one is in the opposite direction from the line of reflection, alright? Notice also that this angle here stayed 66 degrees just like it did with the original angle, which was 66 degrees. Alright, reflect figure R and triangle EFG across line L. Label the reflected images. Do that with your partner. Go. It's good. We do expect you to struggle on this one, which is why we put it on this. Also, this is a different type of reflection. Now it's a horizontal type reflection because the line of reflection is, well, horizontal. Okay. So what we got to do on a problem like this one is start ignoring the lines. Okay. And just focus on the points. All right. So again, I know F is about that far away from the line of reflection. So F prime is going to have to be the same distance away from the line of reflection, just down here. Okay. So this one would be F prime. E as well, this one is about that far up from the line of reflection, so it's going to be reflected this way to E prime. This next part, G, is about that far away from the line of reflection, so we've got to do it the other direction, the same distance, which would be about right here at G prime. The final thing we need to do is just connect these points to show the shape on this thing. So here we go. Something like this, alright? So maybe this is helpful. Alright, now it's been flipped along that line, so some of you guys could say, well, it's kind of like a paper on a string. After you twist it, it kind of starts to flip over like that. And that would be correct, okay? Here's what the other image should have looked like. Connect F and F prime. What relationship does the segment have with the line of reflection? Let's take 1 minute with your partner and talk about that. So yeah, this is the line we're comparing, the red one with this line of reflection right here. On this one, we're comparing that red line that connects F and F prime with that line of reflection. What we're really looking for is the angle that's created by the two. So this one is going to create some kind of 90-degree angle, which we show with this little box. You can just label it 90 degrees if you want. However, it's also important to know what this vocabulary is, because it was part of the objective for the section. This is what we call perpendicular. These two lines create a perpendicular relationship. Alright, just below that in the box, you have something like this. We're going to read these. So this first point, a reflection maps a line to a line, a ray to a ray, a segment to a segment, and an angle to an angle. The second one, a reflection preserves length of segments. And the third one, a reflection preserves measures of angles. All three of those are really just saying that we're not changing the size of the shape, the length, or the angles, or the shape. Whatever it is that we are reflecting will stay whatever it is. This next part, if the reflection is across a line L and P is a point not on L, we're going to skip all that garbage because it gets really technical. In any case, what we're saying right here is we got these 2 points, P and P prime. P prime is the reflection of P over this line of reflection right here. So there's two things we got to remember on this. Is P is the same distance to that line of reflection as P prime is. So that means that that middle line is what we call a bisector of the line that connects P and P prime. We'll just make it one big green line right there. Not only that, but it creates a 90-degree angle, which means the two lines are perpendicular. This is true no matter what. So if we took this line and then made it angled like this, and then if I took some point right here like P, then I would reflect it to P prime. If I connected these 2 points, it would still be 90 degrees, and the line of reflection would still be halfway between the 2 points. In this part, you guys have these figures. There are missing points, I guess, that are labeled. Missing labels for the points on these figures. Take a moment with your partner and figure out what labels are missing, and then label them. So a couple of them, this first one here, I. its reflection would be I prime, and it's not labeled right there. Not only that, but J also, well, this J prime would correspond with this point, and since we already have the image, J must be the pre-image. So it's just labeled J. Down here we've got F, which is labeled, so this is the reflected image, which means that this one has to be F prime. Same with H. Here we have H. Over here with the reflection, this must be H prime. And then we got the point here at the bottom as well. Well, it's a reflection of the K at the top. So this point down here is going to be K prime. Now that's just the points. We should also label any missing angles. So let's go through this. This angle is not labeled right here. And it corresponds with this angle, which means it's 28 degrees. Same with this angle down here. It's reflected up here at the top. So this one also must be 31 degrees. Those are all the angles we can label. Next up, use the picture to label any missing lengths. For example, we got this length at 4 units. It's been reflected up here between H prime and F prime. So this one also would be 4 units. But also this line between I prime and J prime. So the original pre-image line also has to be the same length, 7 units. How does a reflection change the size of an image? And also, how does the translation change the size of an image? Take a moment to write a sentence for both of these. Alright, we should have something like this. A reflection does not change the size of a shape, but a translation also does not change the size of a shape. This would be pretty crucial if we want to keep shapes the same size. It means that we can perform a reflection and translation, which will move them. Reflections will change the orientation also, but it will never change the size of the shape. Neither of these will. Alright, so here's the objectives once again. I know that a reflection will not change the size of an image. That's what we just barely talked about. I know that the line of reflection is halfway between the image and pre-image, which we talked about with that diagram. I know that the line segment created by the image and pre-image is perpendicular with the line of reflection. And this is pretty crucial to know. We won't go into too much detail with any of these in 8th grade, but in 9th grade you guys are going to go very deep into these. Alright then, this is the problem set, which is on the next page. In the picture below, angle DEF is 56 degrees and angle ACB is 114 degrees. AB is 12.6 units, JK is 5.32 units. Point E is on line L, and point I is off of line L. Let there be a reflection across line L. Reflect and label each of the figures and answer the questions that follow. Take a moment and actually we'll give you guys several minutes to do this with your partners.